Welcome! We learned there is no general rule for calculating integrals of compositions of functions. We can, however, calculate integrals with a linear function within a more complex function. For example, we can integrate the function cosine of 2x plus 5. Here, 2x plus 5 is a linear function inside the cosine. Linear functions involve scaling, that is, sending x to a multiple of x, and shifting, adding a constant. Let us consider these two operations separately. We first consider the integral of f of x plus c. The graph of f of x plus c equals the graph of f, but shifted c to the left. The integral of f of x plus c therefore equals the integral of f. But we have to be careful about the endpoints. Indeed, they have to shift by c. So we obtain that the integral from a to b of f of x plus c dx equals the integral from a plus c to b plus c of f of x dx. If we consider the graph of f of 2x, we see that we compress the graph by a factor of a half towards the y-axis. The area under the curve is thus also halved. Notice that the endpoints of the integral have been multiplied by 1/2 as well. If we call the new endpoints a and b, the old ones were therefore 2a and 2b. Thus we find that the integral from a to b of f of 2x dx equals 1/2 of the integral of 2a to 2b of f of x dx. More in general, the integral from a to b of f of cx dx equals 1 over c times the integral of ca to cb of f of x dx for any constant c. One might wonder what happens if c is negative. Well, let's consider the graph of f of minus x. This is the reflection of the graph of f of x in the y-axis. The area under the curve remains equal. However, notice that the order of the starting point and the end point have been interchanged. Thus, we have to add a factor -1 to account for this change. As a result, we find that the integral from a to b of f of minus x dx equals the integral from minus b to minus a of f of x dx, which equals minus the integral from minus a to minus b of f of x dx. Remember that this only works for linear substitutions. These rules do not allow you to calculate the antiderivative of functions like cosine of x squared, where we plug a nonlinear function such as x squared into the cosine. Now, try to calculate the integral of cosine 2x plus 5 yourself.